All right, a brochure inviting subscriptions for a new diet program states that the participants are expected to lose 22 pounds in 5 weeks. So that's their claim. And since that's their claim, we're going to say that's true, and we're going to say that's the mean. So the mean is of the population is 22 in 5 weeks. Suppose that from the data of the 5-week weight losses of 56 participants, so N is 56, the sample mean and standard deviation are found to be 23.5 and 10.2. So we have X bar as 23.5, and this is really important. This says it's the sample standard deviation, which means S is 10.2. And because we are working with the sample standard deviation, we're going to have to use a t-statistic. And our formula for that is t equals x bar minus mu s divided by the square root of n. Also, while we're doing this, we should go ahead and calculate our degrees of freedom, because remember, there is a separate t-statistic for every degree of freedom. So in this case, our degrees of freedom is n minus 1, or 56 minus 1 degrees of freedom in this case is 55. All right, we're going to go ahead and plug into the formula, but before we do that, let's go ahead and draw our little graph. And the claim is 22, but we got a sample of 23.5, and we want to find out how unusual that is. Well, since we're talking about unusual, we're going to want to shade off to the right, because the farther and farther it is away from the mean, the more unusual it would be. So we're looking for the probability that t is greater than or equal to 23.5 minus 22 over standard deviation of 10.2 divided by the sample size. All right, so go ahead and calculate that out. And when I calculate my t-statistic, I find out that the probability that t is greater than or equal to, by doing the math, 1.1005. Now, going to my calculator, there's two different ways to do this. There's an easy way and a longer way. You have to know how to do both, so I'm going to start off with a longer way. So second vars, TCDF, and my lower bound, just looking at my diagram, is 23.5. My upper bound is 99999, just like we've done in the past. And my degrees of freedom, again, is the 56 minus 1, or 55. Notice I am not able to input actual values into this, and I did something wrong. So let's go back, second vars, TCDF. I used actual values, and I wasn't supposed to. I have to use my actual t-statistic, which in this case is 1.1005. And that gives me 0.1379. Now, it's really critical that you're able to calculate this using a t-statistic, because sometimes they'll just give you a t-statistic. But the easier way is to go stat test, so select t-test, and at this point we can go ahead and use actual values. We're going to highlight the word stats for statistics because they gave us the statistics. Well, our mean, they told us, was 22. Go ahead and highlight stats. They told us our mean was 22. They told us our X bar was 23.5. They told us the standard deviation of the sample was 10.2. And they also told us that the sample size was 56. So I'll go ahead and input the actual sample size. Now this is where it gets a little tricky. I have a not equal to, a less than, or a greater than. I need to look at what I used in my equation. Well, I used greater than, or I can look at my shaded portion. So I used a greater than. So I need to make sure greater than is highlighted, and it is. And once again, Now it actually gives me my t-statistic, which is what we had before, but it also gives me my p-value, my probability of it happening, which is 0.1379.